You know, my eventual goal for these classes is kind of to put lectures out, and then our meeting time would just be kind of what we call recitation time, where you've watched those, you've tried the problems, and you come and go, "Hey, I did that. Now, help me with this." Let me pull let me pull those problems up. So, okay, so I have two voltages. Here's a single op amp shown under two different conditions. Determine the voltage gain of the op amp. Okay, I'm gonna let you. So yeah, we can work this problem. So this has a resistor. I like this one because this is how we set up the lab, so you can have the various input voltages. Yeah, I know somebody. I've always joked that in like the lecture halls, we should put out a thing at the beginning of the semester and kind of see whose seats there are, because it always messes people up. You've been sitting in the same place, and all of a sudden you're looking, I see it here with the lab spots. Somebody comes in at a different time. Okay. Doesn't this give you the voltages?
Yeah.
12 volts.
So these are about 12 volts, but these voltages are two different voltages, right?
Top one's 1.
What?
The top one is 1 volt.
Okay.
V out, and then the other. Or wait, I can't read the text; it's too small. But it's the next one is 1.00003. 4 zeros.
And this one's exactly 1?
Yes.
Okay. And what was your output?
1.5.
1.5? Okay. So for an op amp, we know that op amps gain, well, let's do it this way. We know the output. So for an op amp, we know that the output voltage, this is true of any amplifier, so I'm just going to write down this way, is equal to the gain. By the way, sometimes they use a capital G, which would probably make more sense, but most texts use the A, which is amplification. Sub V for voltage, so we're not looking at current or power, not that we can't have those, but this is what we're looking at, times the input. So this is really just two variables, right? We're engineers, we like our subscripts to make things as clear as possible, as long as you know what the subscripts are. Otherwise, they make it probably a little confusing. So I have my gain times my input. This all comes from the fact that gain itself, just as a reminder, by definition, if I measure output and I measure input, that's gain, right? Okay, so the reason I wrote that out, this doesn't answer this question directly. That is the general equation for the amplification of everything. Take the input voltage, multiply by the amplification of the device. Or, that is the base definition, the amplification, is the output over the input, which will help us answer this problem, because that's what we want to solve, right? That's what we're trying to find, is the amplification of this op amp, right? All right, so what's the output voltage? What's the input voltage?
There's 2 of them.
Right, but what's the input voltage of an op amp? It's the non-inverting input minus the inverting input. Yeah, so remember I did some of these do some of these on Tuesday. I gave you the numbers. Well, I guess you give them here too. So 1.5 volts. This is, I don't know if I have these lined up the way that one does, but that's okay. You can take the concept and solve your own. I bet, is this the non-inverting input on the one you guys have on the bottom?
Looks like it.
Okay, I'm going to switch that real quick to match it. Just because we wouldn't actually give a negative gain for the amplifier. Your circuit can have a negative gain if it's an inverting op amp. So we're going to take 1.0003 volts minus 1. There's 4 zeros, right?
Yeah.
1.0000 volts I'll end up with 1.5 volts over 0.00003 volts. That's the difference in those two. So that will probably be a big number. I say probably, it's obviously a big number, right? 0.00003. So I get 50,000. So that op amp has a gain of 50,000. Does that seem reasonable to you from your common sense understanding from my one day's lecture and your however much time you spent reading the text? Yeah, right? What did I say gain for a typical op amp is? See how much attention people paid to me on Tuesday. Because I said it several times. What did I say gains for op amps typically are? Up in the 100,000 range. I mean, 50,000 is not 100,000, but sure, op amps can have a little more. But yeah, op amps have huge gains. They take the difference in the two inputs. That's exactly what they do. They take the difference in the two inputs, amplified by the internal amplification, which is up in the 100,000s range. Typically, for modern ones. So one of the things we like about them is that they do this amplification. This is a bit about how we could go build this in class, couldn't we? I just get a 12 volt supply, connect 12 volts to this, negative voltage over here. Use a couple of potentiometers, set these voltages, and then I would probably set one. I'd probably just plug one in at a certain voltage, and then just set the other and turn it a little bit, and see. I should have a gain across the whole region. Okay. Are there other? I'm glad you started the homework already. That's good. Everything I covered on Tuesday, everything should be what we need to solve these problems. So that's the first couple problems are like that. I believe after that you look at an op amp with different input voltages and output. But they're all the same sort of gain problem, and I believe you have an inverting and non-inverting op amp in the end that are just like what we did on the Tuesday examples. I'll write them down again. Do I need to solve these, or do you think do you think what I covered and looking back at what I did then is enough? I'll go build them for you if you want to do that. Let's choose here. So. Inverting op amp. If I have this circuit, let's just make up some numbers. Let's make that 10 kiloohms, that 120 kiloohms. Maybe I have 20 millivolts. What's my output voltage? What's my current through the loop? I call that the feedback current. What's my current in? How would I find those?
Start by getting your A for your gain.
Yeah, I can find my gain. What's my gain?
Resistor 2 divided by resistor 1 plus 1.
Right, gain by definition, so we found this, it's an inverting op amp, so I'm going to the inverter, so I need a negative. It's the feedback resistor over the input resistor. Feedback is 120 kiloohms. Feedback is 10 kiloohms. So my gain will be minus 12.
Is it the non-inverting one that you add 1 to?
Yes.
Okay.
And I would write those equation sheets down, or those equations down, on your equation sheet. I would not try to memorize those. I mean, if you want to memorize them, great. But I would depend on it. All right, so my output is my gain times my input, and my gain's minus 12, and my input is 20 millivolts. So 20 times 12 looks like it's going to be 240. So if I measure my output voltage, it's going to be minus 240 volts, or millivolts, I'm sorry. So my output is 12 times bigger than my input, and it's negative because it's an inverting op amp. This is why I have to have a positive and a negative power supply. That wasn't very hard, was it? These are easier than BJTs, I think. I mean, the only harder thing when you connect them is making sure you get the negative and positive power supply. Okay, let's go find our currents. How do I find those? Let's start with my assumptions. We had 2 assumptions we said we can make on all op amps. What were those? I laid them all out, I wrote them in detail on the board, and we used them to solve them. I'm pushing this to make sure that you look back and notes the 2's going to
Input currents are equal, less than or equal to 0.
Yeah, they can't be less than. They're just 0. So our input currents here, we have an assumption that this current, I'll make it an approximate, but remember, how small are these? Somewhere down in the nanoamps probably, because the input impedance is extremely high in my op amp. Ohm's law, voltage over current. Okay, so those 2 currents are basically 0. For calculation purposes, they are 0. I always specify this because if you hook the thing up and you don't put anything into it, it doesn't amplify because there's no current. But it's just very, very tiny. Okay, what are the voltages? Well, the inverting voltage ought to be pretty easy. What's the voltage of ground by definition?
0.
0. I mean, that's what it is, right? That's a 0 point. And we said our 2 inputs have the same voltage. Once again, because what's happening, if this thing internally has a gain of 50,000 or 100,000, I'm amplifying a tiny, 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 tiny little difference between these 2 voltages. Again, if I put identical voltages in both of them, I'll get 0 out. But if I have any difference at all, this is amplified. That's the whole goal of it. So this actual difference is going to be down in the microvolts, or even nanovolts. It's going to be dinky, very, very tiny. So having said that, what's my current then? These 2 assumptions, all op amps, put those on there, you're done, do your calculations, because now you make the problem just kind of trivial. Your current here, by Ohm's law, voltage over current. So I went from 20 millivolts down to 0, so I dropped 20 millivolts over 10 kiloohms. What's 20 millivolts over 10? That seems like something I should be able to do in my head, but I'll mess a decimal point up. So 0.02 volts divided by 10,000 ohms is, I mean right there, 2 times 10 to the minus 6 microamps. So my input current is down in the microamps. What's my current going to be over here? I mean, if this current in is 2 microamps and none of it's going to the op amp, then this is 2 microamps over here too. But I can also calculate it. So let's calculate it. The voltage, I go from 0 to 240 millivolts. Over 120 kiloohms. So I do 0.24 divided by 120 kiloohms and get 2 times 10 to the minus 6, which is 2 microamps. So I can calculate it. Notice my math even works out perfect, right? 0, I'm going to get the 1 voltage minus the next one, which is negative. It gives me a positive number. So that's correct because my current's flowing in and around. There you go. I got my currents, I got my voltage, got my output. I'm done.
So what parts of the problem change if your power supply for the 20 millivolts is on a positive, but all your resistors are in the same spot?
Well, it can't be in the same spot or it won't do anything interesting. So let's make it, we could take it and build it as inverting, non-inverting op amp, but I actually have to do a little bit of other switching. So if I take that same circuit make it non-inverting, I have to go straight in, but my two resistors are still connected to the inverting input. So 20 millivolts. So now this is my ground resistor, which is 10 kiloohms. My feedback is still 120 kiloohms. It's critical that in either case, my output is connected to the inverting input. That makes it gives negative feedback, which means it helps constrain the gain. Negative feedback. Yes, again, what we want in the electronic world for almost everything is negative feedback. Because that means as the output gets bigger, we reduce the input so we constrain the gain. As the output gets smaller, we pull off of that so it lets the gain increase. So we're hoping to constrain that gain, which does two things. The one doesn't let it go way out of control. The other it does is it allows for the individual variation of op amps, because these things, they're inexpensive. We buy them by the hundreds of thousands to put in things, and they have some variation in the internal gain, 10% or 20% or something. That way I don't have to worry about testing each one. I can just plug one in, it's gonna work, because if it has a little more gain, then I'll end up with more coming back through my feedback resistor, reducing the gain. If it has a little less, I'll have less coming back, letting the gain be bigger, and it'll work out to be the same. Close to the same. Obviously there are actual differences, but close enough. You'll notice electronics is a lot of, you would think this is all super precision, but we use 10 and 5% parts everywhere. Okay, so what's my gain for this? You already mentioned it.
Same thing plus one for the.
Well, it's the feedback over the ground loop technically, because the resistor, because this is going from the inverting down to ground. But yeah, so you are going to end up with 1 plus 120 kiloohms over 10 kiloohms. 120 over 10 is 12, plus 1 is 13. So my gain in this case is 13. So therefore, my output voltage is the gain times the input. 20 times 13 is 160 millivolts. It's non-inverting, so my positive input gives me a positive output.
Did you not add one on your other example?
I don't, because that's a different amplifier.
Okay.
It's not part of this one. I can have a gain of 0 here. I can never get less than a gain of 1 there. That's why we can build that buffer that we talked about last time. Okay, now what else can I do? My current here. What's my current? Oh, don't make this harder than it is. What do we say my assumptions for my op amp are?
Super high impedance, so it should go to 0.
Yeah. My current's 0. My current's 0. Ideal op amps, the input current's always 0. Real op amps, the current's probably so low you can't even measure it in the lab easily unless you have very sensitive equipment. It'll be neat. Okay, my voltage up here is 20 millivolts. What's my voltage over here?
0.
No! My two inputs, okay, don't let this confuse you. Over here, they're both 0 because this one is tied to ground, which is 0, which means that's 0. Over here, this one is 20 millivolts because we're tied directly to a 20 millivolt source. Therefore, this one is also 20 millivolts. I didn't say that one of them is 0. I said they're identical. So I look and figure out which one of them is set by the surrounding stuff. It's connected directly to ground, well, that's 0. Is it connected directly to a power source? Well, that's that voltage. And the other one has to be the same. Or the way they won't be is if you intentionally hook, if you hook one to 20 millivolts and hook the other one to ground, then you're going to just have a mess. So we won't do that. All right, so now if I wanted to find the current through this, what would that be? Ohm's law. Right? Yeah, don't make these harder than they are. It's always Ohm's law. You know the voltage, you know the resistance. It's 20 millivolts over 10 kiloohms, which is going to be, when you calculate, you know, you got to put all your powers in there. I'm kind of assuming you have that down now, but if you need help, let me know. Right? 20 times 10 to the minus 3 divided by 10 times 10 to the 3, and you'd end up with 2 times 10 to the minus 6, which is microamps. And the current through here is going to be what? Well, I can just look and say it's got to be 2 microamps because none's going up there, so it's all going down here. But I can also calculate it, right? I take that voltage minus this, the voltage across the resistor, so V out is 160 millivolts minus the voltage here. Be careful, you do not have 160 millivolts across that resistor. You have 160 and 20, so therefore you have 140 millivolts across the resistor. So it's only what, you know, the difference in the two ends. And the resistor is 120 kiloohms. That ends up being 140 millivolts over 100. Something's wrong there. Oh, this is dumb up here. Somebody should have got my math there. 13 times 20. That's better. 260 millivolts. I would like to say I put those up there to make sure you're paying attention, but honestly, sometimes I just make little arithmetic errors at the board on arithmetic that you can do as well as me. I know the electronics, but multiplying. So 240 over 120. 2 times 10 to the minus 3 over 10 to the 3. 10 to the minus 6, which is.
I do not think about it like that.
You can plug it all into your calculator if you want. But we have powers. 10 to the minus 3 divided by 10 to the 3 is 10 to the minus 6. That's the way I can do something like this.
Sure. I just saw the 240 and 120.
Which gives you the 2, and then you just got to make sure it's the right 2. It's not 2 amps, not even 2 milliamps. So then you want to plug in your power. Like I said, ask me. I know I'm doing those quick. Part of this is because I worked through very detailed examples of these. Tuesday I already posted them. So I don't want to linger so long that I don't have time to set up the build today before people leave. Questions on these? This should answer everything I asked you on the last 2 pages of this homework set, and everything you do in the pre-lab portion and the lab portion for calculations for this week's lab. But I also want to answer questions. I don't know why. I feel like op amps are some of the easiest to work with that we do of anything in here past basic resistors. On the other hand, they do have a bit of a mental block. I know from teaching this where some people are like, oh yeah, that's easy. I just put these calculations. Other people are like, wow, that triangle is confusing. And that's okay. So I want to answer questions. What I find is usually, for some reason, BJTs, people get going a little easier, but I feel like the math is actually quite a bit harder on them. And op amps, the math I think is easier, but it's a barrier. Sometimes people hit that barrier. It's like, no. So you have to get past it, and that's what I'm here for. And a reminder, and I'm saying it now because I have recorded every single thing I've done this semester. Make sure you're going out to those videos. If you didn't get here Tuesday, you should have been watching that whole thing before you got here today. And then you can ask me. Yeah.
I think the lecture is up.
Oh, I'm sorry. If you don't see it out there, you can send me a message and remind me, because I'll upload them as soon as I'm done.
I requested another video, or it was the in-class video for op amps.
Okay, so it's not, and I didn't post it?
It's posted, it's just not, you have to request.
Oh, that's an old one then.
Yeah, I think it is.
No, I recorded Tuesdays. Okay, then that's on me. So I'm going to stop this one. I'll do more if we're going to.